Hi there, welcome to eSkill Point. This is Sailesh, welcoming you on this channel. Today we are going to talk about geometric mean. Now, for you to understand geometric mean, which is a part of the Pythagoras theorem, you would need to recall a few of the postulates which you would have remembered in your previous class. Now, we remember that there are similarities which are proved between two triangles, and once the triangles are proved to be similar, then the sides are proportionate to each other. Let us also refresh and recall what we have learned in the past. Now we need to understand that we have followed certain theorems in the past, which is angle side angle postulate, angle angle side postulate. Now these theorems are based on the basic foundation of your knowledge of the postulate, which basically helps us to understand similarity. Now in the geometric mean, we would be needing you to remember this, that in a right angle triangle, if the altitude is drawn to the hypotenuse, which means that the vertex opposite the hypotenuse, you need to draw a line which perpendicularly lands on the hypotenuse, and then what happens is this right angle triangle gets split into two triangles. Now what happens with these two triangles? These two triangles are actually similar to the mother triangle, and hence they are similar to each other. Let us now prove what I am just talking about. Look at these triangles, okay? The triangle LMN, and which is green in color, and the triangle LMN, the one which is yellow in color. It is very evident that these two triangles are similar. Let us move ahead and watch how we prove this theorem of the geometric mean. Let's look at this similarity and the right angle triangle. Now here, look at this figure ABC. In a right angle triangle ABC, if the altitude is drawn, now here the altitude we are referring to is as BD. Now when you're looking at this figure, here I'm talking about this, which is BD. Now the BD is the altitude which makes a perpendicular to the hypotenuse AC at D. What happens? There are two triangles which get formed, which is the triangle ABD and the triangle DBC. Let us look at how we prove that these two individually made triangles are similar to the parent triangle or the mother triangle. Okay, so we are looking at the triangle ABC. The angle B is 90, which is obviously the case. Segment BD is perpendicular to AC. So BD is perpendicular to AC. So to prove that triangle ADB. So here we are trying to prove that the triangle ADB, which is this triangle, is similar to triangle ABC, which is the parent triangle. And again, we have to prove that triangle BCD, which is this triangle, is similar to triangle ABC, which is the parent triangle. Hence, this triangle, which is ADB, is similar to BDC. Okay, let us prove this. I'm gonna split this triangle for the benefit of your understanding. There you go. Now we have the triangle ABC, which has got split to two triangles. Now it is easier for us to visualize how these three triangles are similar to each other. But first we will prove that how the child triangle is similar to the mother triangle. So we are here talking about in triangle ADB, which is this triangle, okay, and triangle ABC, which is this triangle. DAB and BAC is the common angle. Now again, we know that the angle A, which is X, is similar in both of them. So there is a common angle. Now there is a ADB. which is ADB, which is 90 degrees, and also there is a ABC, which is 90 degrees here. Okay, we're talking about this 90 degree here, and you're talking about this 90 degree here. Now, when you're looking at this triangle, here we have a common angle, two common angles, and at the same time, we say that using the AA postulate, triangle ADB, okay, let us call this the triangle number 1, okay, which is the triangle number 1 here, is similar to triangle number 3. Let me call the bigger triangle the big with a bigger number. So this is the triangle number 3. Great. Using the AA test. Again, the hypotenuse which was split, or the altitude which split the triangle, made another triangle called BDC. So in triangle BDC, which is this is actually the triangle number 2, okay, and in ABC, the parent, the mother triangle, again there is a common angle which is Y in this case, okay, and there is a 90 degree. Again, we have a B here which is 90 degree, and we also have the angle D which is 90 degree. So angle BDC is similar to angle ABC 90, using the same formula. Triangle BDC, that means the triangle number 2 is similar to triangle number 3, which is using the AA postulate. Now we have got some good proofs. We have proven that now 1 is similar to 3, 2 is similar to 3. What does it mean? From transitivity, 1, 2 and 3 are similar. Now this is the basic foundation which you need to remember, that what happens when the altitude is drawn from the vertex to the hypotenuse at 90 degrees. The geometric mean is now actually a formula which we will see ahead. So the theorem of geometric means says that in a right angle triangle, the perpendicular segment to the hypotenuse from the opposite side is the geometric mean of the segment into which the hypotenuse is divided. Now we saw in the earlier slides that the three triangles were similar. Now when the triangles are similar, the sides of those triangles are proportionate to each other. So the ratios may change, but they are proportionate. So let us look at these three triangles here. The proof is in a right angle triangle PQR. Let's look at this triangle PQR. The segment QS is the perpendicular to the hypotenuse PR, and so triangle QSR, which is the QSR, which is this triangle, is similar to triangle PSQ, which is PSQ. So QSR and PSQ. So QSR, which is this triangle, is similar to PSQ. We saw it in the previous slide. Hence, QS. Now QS is this segment upon PS. So here is QS upon PS. So we are talking about the small triangle. So QS upon PS is equal to SR upon SQ. So when we write this, we also say that QS upon PS is equal to SR upon SQ. So we now do a cross multiplication, which means that QS square, if you see this, there is a QS here and there is a QS here. So QS square is equal to PS into SR. So this is plainly mathematics and cross multiplication. Hence, segment QS is the geometric mean of segment PS and SR. Now it is very easy to understand. We understood, in the last few videos there were certain formulas, okay, which were important for the Pythagoras theorem. This one also is an important theorem for you to remember. The formula is very easy. It says that the altitude which is drawn to the hypotenuse, the square of the altitude is equal to the two segments SR and SP here. So if this segment 1 here and this is segment 2 here, so there is PS, which is segment 1, this is 2. So this is very easy for you to remember, my dear friends, that QS square is equal to PS into SR. Therefore, segment QS is the geometric mean of segment PS and SR. Uh, you would need to write exactly the same way as we have written this theorem. By this, you would have understood most of the theorems in the Pythagoras theorem. We will meet again in another video. Till then, take care and bye bye. This is Sailesh Bhatia. You have a lovely day.